Hello. In this lesson, can we learn how to do translation on the coordinate plane? So, if you are taught to translate a figure on the coordinate plane on a graph, the first thing you need to know is we use a translation vector, which you can just assign it values A and B. And then the rule is the translated figure coordinates should change from x and y to x plus a, where a is the first value of the translation vector, and then b, y plus b, where b is the second value of that translation vector. So with that knowledge, can we try an example? So you are told triangle ABC has the vertices A, which is 0, 0, B, which is 3, 0, and C, which is 1, 3. Then it is translated by a translation vector of 2, 2, where now in this case A takes on the value of 2 and also B takes on the value of 2, this one. And then you are told to write the coordinates of the translated triangle. So how do we go about this? So these are the original coordinates, and of course our translation vector, which you can call it B, is given by 2, 2, like that. But then the rule to translate this one to, we need to have the translated values, our coordinates for A, for B, and for C. So the rule which applies, of course, we said we take all the x coordinates, which are those ones, we take them x plus a, where a is the value for the translation vector, then comma, then we take all the values, the y values, these ones, and we add b, where b is the second value of the translation vector. So in our case, we have the first one, we have a, x is 0, so we take and a is 2, so it will be 0 plus 2, which will be 2. Then for y, it will be 0 plus again 2, because also the translation vector here is 2, so it will be 0 plus 2, which is also 2. Then we repeat the same for b, which we have 3, but now 3 plus 2, which is 5. And then again y, which is 0, but now plus 2, which is 2. And then we go the same for c, where we have 1, and then plus a, which becomes 3, and then we have the y1, which is 3 plus y plus b, of course, 3 plus 2, which is 5, and this becomes the new coordinates of the translated triangle. So this is the logic we use when we are applying the translation vector to translate figures on the coordinate plane. Can we try another example? So in this one, you are told triangle ABC has vertices negative 1, 2, B1, 2, and C0, 4. And then it's translated to triangle ABC. We can put these ones there by the translation vector negative 2 and negative 3. Then, of course, you are told to translate it and write the new coordinates of the translated triangle. So, how do we go about this? These are the original coordinates, and the translation vector b is given by negative 2 for A, and then negative 3 for B. I think so. Yes. So from there, we apply our normal formula, where we have all the coordinates of x taking on the value plus a now to get the new values of a, then those of b, or the coordinates for y, we'll say y plus b, then to get the coordinates, new coordinates of all these coordinates here. So we start with this one, but you see here they are already negative. So this negative here will change our signs here. So for example, if we have the first one, then you here, which is now the translated one, you know that it is -1, but then we are adding here, but you see our here was negative. So now positive multiplied by negative, it's kind of like saying plus, now minus this 2 for here, which now becomes -1. So now positive multiplied by negative is negative, so -2, which now becomes -3. So our first coordinate here become -3. Then we repeat the same for b. It now becomes y plus b, and our b here is -3. So we have and here is 2. The y value for here is 2. Let me first label them and that. So 2, and now plus in brackets -3, like that, which now becomes 2. Positive multiplied by negative is negative, so it is 2 minus 3, which becomes -1. So the value here become -1. Then we go to be translated. We apply the same logic, and we have 1. So we have 1, but now plus a, but our here is -2, so -2, which now becomes 1 minus 2, which is -1. I will put -1 there, and then we'll go again to b, y, which is y plus b, and we have 2, so it is 2, and now 2 plus b, our b here is -3, so -3, which now becomes 2. Positive multiplied by negative is negative, so -3, which becomes -1, 2. So yeah, it also becomes -1, like that. And then we go to c, which we have 0 and x plus a, so of course 0 plus our a is -2, so it will be a -2, which becomes 0 minus 2, which is -2. So yeah, it becomes -2, and the last one is 4. So 4 plus b, and our b is -3, so it becomes 4 minus 3, which is 4 minus 3 is 1. So it becomes 1, and this becomes the new coordinates for the translated triangle. What about if you are given a question like this, question 3, where you thought triangle PQR is marked triangle that one PQR, but now translated, and you are not given the translation factor, but you are given the original coordinates of the triangle and the coordinates after translation. Then the first question is plot both triangles on the grid, or in short, plot them on the Cartesian plane or on the graph. So we can just start there. Let us plot these two triangles on the graph. And the original one, we have -2, -1. So we can come in our graph and plot that one. The first coordinate is -2, -1, somewhere there. Then the second one is 1, -1. So it is 1, -1, somewhere there. And then the third one is, what is the third one? The third one is 0, 2. The third one is 0, then 2, somewhere there. And then that is the original triangle. We can actually fill it like that. And then it is translated by a certain translation factor, which we don't know. And then the new coordinates of the translated one becomes these ones. And we are also supposed to plot them in the coordinate plane. So we have 1, 2. Let's plot them. We have 1, 2, 1, and 2, somewhere there. Then the second one is 4, 2, 4, and 2, somewhere there. And then the third one is 3, 5. Is 3 and 5, 3, 5, somewhere there. And that becomes the translated triangle. So now, you have already done the first part where you are told to plot the triangle on the grid. And now the second one, you are told to find the translation vector that maps this PQR to this translated PQR, of course. So what we can do from this one is we can pick any of the coordinates, but even before we pick any of the points, remember our original formula was if I have A and it has X and Y, and now it is translated to A, and which now this with a translation vector like A, B, like this, then to get the coordinates of A, we have to take X plus A, where this A was from the translation vector. Then for the coordinate of Y, we had to take Y plus B, where B is from the translation vector, and also the new this became the new coordinates of the translation vector. And now you see we already have in our question we already have the original coordinates, and we also have the translated one. So what we don't have is this one. So what do we do? Don't we take just these translated ones? For example, here we have this X. I can call it like this, and then this way I can call it like this. Then to get, since I added this A to get this one, why don't I take this, I subtract this to get the A, and then I take this Y, I subtract this to get this B. So like this. Now it becomes like X translated minus the original X for the X coordinates, and then Y translated minus the original Y to get the Y coordinates. So can we apply this formula using our normal coordinates, the ones we have from the translation itself and the original one? So let's read them. Of course, our translation vector, let me call it B, and then just take any of these points. Like for example, I can just take R translated and this original R. So for A, I take, of course, the values of X translated, which is 3, minus the original X, which is 0. So now M becomes X, which is 3 minus 0, which is 3. And then from B, I take the values of Y translated, which is 5, then minus the original Y, which is 2. So 5 minus 2 is 3. 2. But now that becomes the translated, the translation vector. But just to confirm, we can also check if we repeat the same process for Q for P, it will give us the same translation vector. So can we try with Q? So Q translated becomes the first one for him becomes 4 minus 1, which is 3, and then the second one becomes 2 minus it is, let me write it somewhere here. It is 2 minus, but you see we also have this as negative 1. So it will be 2 minus 1, which will be 2 plus 1, because negative 1 by negative is positive, so it will be 2 plus 1, which is 3. So Q gives us still the same translation vector. We can then confirm with P, which I can say the first one, of course, the translated X here is 1, then 1 minus, but we have negative 2 there, so minus 2 again, it becomes 1 plus 2, which is 3. So here we have 3, and then again 2 here, minus 1, because we have 1 above them, which now becomes 2 plus 1, which is also 3. So all the 3 points give us the same translation factor, and then it means the translation factor in this case is 3, 3. So that's how we translate figures on the Cartesian plane. If you have any question, if you don't understand some of these parts, you can ask me on the comment section. I'll try to solve any question you have to my level best. And bye for now. Let us meet in the next lesson.